We did 39.
What number is this one?
39.
39. Tres y 9. Trying to work on my Spanish a little bit. Okay? Anything else we need besides 39?
I did 41.
41. And we have number 45. Okay. Let's go ahead and get my microphone plugged in here. Blink. Okay, let's have a seat. Got all your stuff memorized yet? I'll let you use a sheet tomorrow, but we'll probably do something next week where you've got to fill one in for me. Okay? Okay, so 39. This is the first of three of them, so hopefully this one will go the best. Okay. So what we have is we've got a nested function. So that's going to be a composition of two functions where we're going to have to use chain rule. And we also have a product. So we're going to have a couple different things going on, product rule and some chain rule. So I'm just going to rewrite this so it's more friendly to me. This is y equals, I'm still going to simplify it. I'm not finding the derivative. Let's work on our notation. X tangent of 2x to the 1/2 plus 7. Okay, so now let's differentiate. dy dx. Okay, let's make this u and this v. So du 1 times, and then leave this alone. Plus this times the derivative of tangent. What's the derivative of tangent? Secant squared. Ooh, that would actually be a good bonus. I know what I'm going to do. So I will give you a sheet tomorrow for you to fill out. If you get them all right, that'll be your bonus for tomorrow. For the trig stuff. Okay, for the trig stuff and law of the quotient rule, all that good stuff. Might even be worth a couple points. Okay, and then what you'll do is you'll give it to me right away. I will correct, make changes, and then you'll have a sheet for the test. Make sense? Okay. Secant squared of 2x to the 1/2. Now, since this is a nested function, I just found the derivative of the outside. Now I got to take it times the derivative of the inside, which would be times x raised to the negative 1/2. Okay. Oh, well, I forgot the derivative of 7. 0, nothing. That's just the height of my function. Height does not impact slope. Okay. So what the heck? Let's simplify it just a little bit. So here I have tangent of the original 2 squares of x plus, okay, x and x to the negative 1/2 gives me square root of x. Okay, because I have x to the first, x to the 1/2, and negative 1/2, I add my exponents. Secant squared of 2 squares of x. Boom, shakalaka. Okay. All right. Here we go, 41. Smoking through this like a teenage delinquent through a pack of unfiltered Camels. Okay. So sine over 1 plus cosine. So what rules are we going to use? Quotient rule and chain rule. Because I've got some blob squared. First thing I've got to do is take the derivative of that blob squared. So let's go dy dx equals 2 times this blob to the first, okay, times, and I'm going to put big old brackets to make sure that I realize that all that is multiplied by everything that's coming, okay? Especially when you're doing like a product rule. If you don't put parentheses, you might think it's just multiplied by the first part. No, it's multiplied by the whole derivative. So in this case, low d high, and I put that in parentheses so I realize it's not minus cosine, minus high d low all over the bottom squared. Okay, there's something that I see in the top that makes me go, ooh. Whenever I see a sine squared, yes. Oh, did I make a mistake? Where did I put that? I'm sorry. You are exactly right. I was just seeing if you're paying attention. Nice job. For that, you can have a donut.
Oh, okay.
Okay? Now people are going to start paying attention. No. Okay, I see a sine squared and I see a potential cosine squared. So if I do tease that out, sine squared plus cosine squared, what is sine squared plus cosine squared? 1. Okay, so I've got 1. I'm going to try and save a little bit of time here. I got 1 cosine plus cosine squared plus sine squared. So it's just going to be cosine left on top over 1 plus cosine theta squared. And then other things we can do, we could simplify this. Sine times cosine. Did they change this to tangent? No. Did they? Oh, no, you can't change that to tangent. Sine over cosine. Duh. Okay. Did they do this?
The answer was like 2 sine. Yeah, and then I think they crossed out a cosine. Because it was like 2 sine. It's 2 sine over 1 plus cosine squared. Yeah.
2 sine over what?
1 plus cosine squared. Oh, can you,
Oh, I forgot my plus 1. I forgot my plus 1. We talked about it. I just let it evaporate. So that cosine plus 1 will cancel one of those. So then we won't have a cosine anymore. So yeah, I could put the 2 on top.
This one come from?
Because my sine squared plus cosine squared. Because if I write this out a little bit better, which I probably should have, it would be cosine theta plus cosine squared theta. I just tried to do too much in my head to save some time.
Okay.
Yep, I know. I should probably just write it from the beginning. $45. Q equals, okay, I'm going to rewrite this, so hence no dq dt yet. Sine of t over t plus 1 to the 1/2. And if you wanted to, you could change this to t plus 1 to the negative 1/2, and then you wouldn't have to use quotient rule. You could use the product rule instead. But I'm just going to go ahead and use quotient rule. You can do it however you want. I think the system is amazing. It comes back to the same thing regardless. dq dt. Now, where does that come from? I'm finding out how fast q changes with respect to how fast t changes. So it's the result over my input. So cosine of this whole ugly thing times low d high minus high d low times the nested function, which is just 1. Okay. And then that would all be over t plus 1. Yuck. And again, for tomorrow, I'm not worried about simplification, but I know that you want to see where this is all coming from in relationship to the book. Ugh. And then, I don't know. I just right now I just don't want to spend a whole lot of our energy on simplification. But I could cancel this. It depends upon whether they want radicals in the bottom or not. If they're okay with radicals in the bottom, we could simplify it some more. But we can just stop right here for tomorrow. Okay. I'm going to go to a blank sheet. Thanks for writing those out and getting us going on that. So tomorrow, let's spend some time taking a look at this. I originally had this scheduled for today, but we're going tomorrow. 3.1 to 3.5. Let's just flip through each section and we'll just talk about what's going to be important and what's not. Okay. Okay, I do want to, I don't know if this is necessarily from 3.1, but I do want to do this. I do want to be able to find a derivative using the fact that f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? So if I give you, those are the ones that, remember, we did them on the board and we kind of came up with our conjectures and this, that, and the other. So if I give you a function, I'm not going to do a trig function, okay, because that's not what I'm concerned about. But if I give you a simpler polynomial or a simple radical, then I would like you to be able to find the derivative using that definition. Okay, let me go through the whole thing, and if you want to work on a couple things, we can. Okay, 3.1. The big thing we worked with there was graphs of f of x versus f prime of x. Okay, so be ready to draw the slope on a graph of the original function. Whatever it may be. So there's some good problems from that section that we've done. You can go back and take a look at those. When we're all done with this, I might pick a couple problems to recommend. Okay. And then basically 3.2 and 3. Okay, we didn't do 3.3. Basic derivative rules. 3.3 we're going to save for later. We're going to save for when we do what's called related rates. Okay. So it's actually only over a few. Only 4 sections instead of 5. 3.4 trig derivatives. And 3.5 was chain rule. And that section also talks about parametric equations, and we're not doing that for right now either. Okay? My goal is to write something that you're going to get done in a period instead of go home, work on some stuff, come back and finish it the next day. So be ready for that. They've got derivative-a-palooza. Let me see if I can find something. Oh. Another thing we did was to, this was from 3.1. Write equation of tangent line. Okay. That's where we did it on the graphing calculator. I probably won't necessarily do it that way. Excuse me. You can always check yourself that way. But that is... Now, I don't by any stretch expect you to do all of this, but to make it clear what you're going to be responsible for, again, I don't expect you to do all this. But if I go page 255 where the review problems are, I would say, let me just take a look at this. Again, I don't expect you to do all of these. I'm just trying to make it clear. That's possible. Not worried about those are parametric equations. Not going to worry about that right now. Okay. 93, 94. Ooh, 99 is a good clarification of that last point that I talked about. Boy, there's so much information in this section. Or in this chapter, I mean. And the rest is related rates. Which that'll be fun for you. Related rates gets kind of cool. Okay. So probably what I'm going to do for tonight and for the rest of the period, as far as that goes, for the rest of the period, you guys can ask me questions. We can do examples, whatever. But overnight, what I'm going to want to see is I'm going to want to see evidence of studying. Okay? So whatever you're doing to get ready, take out a blank sheet and be ready to show me that tomorrow. Okay? I would say anything after we're done today. I want to see evidence of something outside of class. Okay? But yeah, if you do some problems from here, that's definite evidence. You bet. Can you do me a favor? You guys probably have it marked in the back. Can you tell me if the... if...
I don't think they have. No. Oh, wait. That's no.
There's no answers to these in the back at all?
No, there's not. No.
Well, that...
It goes to additional and advanced problems on page 2.
Well, that kind of stinks, doesn't it? Okay. So let's do it this way. Let me see if my solutions manual. You guys can definitely take a... It does have it?
Page 820. Yeah. Oh, that's right there.
It does?
It does.
Okay, you got me all kicked into problem-solving mode, but good. Good. Okay. And I'm a huge fan of you guys leading your own practice rather than me creating a review sheet. And the philosophy that guides a lot of what I do or what you guys are going to be expected to do next year. Your professors won't say, okay, here's your review sheet, do these problems, here's the answers. You know, they're just going to say, here's the information, get ready to go. Okay, what do you want to talk about? Anything. Don't be afraid, don't be shy.
Can you check if this is right? Because I did it like the product rule way, not the...
Okay. Can we just take a look at it as I just show up here without you responding yet? Okay. So this is number 45, which is this problem right here. I want to see it, she wants to see if she got it right using the product rule instead. Okay. First of all, I'm going to make sure she wrote it right. Good. So there's my product rule.
I might not.
No, just have faith in yourself here.
Sorry.
Okay. Cosine. Got this. Good. 1 times this plus t times negative 1/2. That to the negative 3/2. Perfect. Good job. Okay. Okay, after doing this, is there anything you want me to do? Any examples? Or you don't have to have a specific example. Yes, ma'am.
Can you do the top one?
Okay, was that what you were going to say, Melissa?
Oh.
Okay. No, that's fine. I'm sorry, I should use your names. Melissa, what were you going to say?
I feel like it probably like
E to the
squared plus 4.
e to the ugly?
Yeah.
Okay. So we'll do an e to the ugly, and what are you saying?
The x plus h.
Oh, okay. Got it. Okay. So let's find an e to the ugly problem. And I will try and find something, or I can just come up with something that's not that big a deal. I could just come up with ooh, okay. It was kind of fun. We had a lot of kids in here for the Algebra 2 review that I put up for their test. And I do that for the non-college credit classes. And Kat put up that problem right there just so they could see it, and they were all kind of throwing it up in their mouths a little bit. So they're like, ooh, there's words in math. What else did they say?
Erica was like, where's the number?
Oh, there's a little number here and there. Okay.
Sometimes I forgot that there was numbers.
Oh, yeah.
More.
Yep. Yeah, you're right. Okay. So let's do an e to the ugly problem. Okay. We'll do a couple of them. So I'm going to do 42. In the back where there's just odds or evens. Do you recall when you looked back there real quick? Just the odds? Okay. Y equals square root of 2 e to the square root of 2x. Okay. Okay. So what rules do we have to use here? Product rule? Nope. You don't have to use product rule. Why? Even though there's a product rule here, this is not a function. That's just a coefficient. Okay? It's just going to be chain. Chain, chain, chain. Okay. So let's go dy dx equals square root of 2 e to the ugly. Okay? Because the derivative of e to anything is just e to that thing. Okay? And now I probably should have written this a little bit better. But this square root of 2x is the same thing as 2x to the 1/2 power. So now let's go ahead and find the derivative of that. 1/2 times 2x raised to the negative 1/2. Am I done? No, this is a chain inside a chain. Because now I just found the derivative of this something to the 1/2 function. Now I've got something when I'm done. Ooh, something inside of that has a rate of change as well. So I got to take this times 2.
So did you get the 2 because it's with the x in the parentheses?
Yes. Yep. So it's another nested function. Because what I have is I've got this square root of 2x is a nested function. And then I've got a square root of something ugly. So then I could take the derivative of the square root and then take that times the derivative of the inside part. Okay. 44. Is that what you're looking for, Melissa?
Yeah. Why didn't you take like the 1/2 and multiply it by like the square root of 2?
I could. You know, I could simplify all this if I wanted.
When you took it originally, like that would have been e to the 2x to the 1/2. Why didn't you take that 1/2 and bring it to the front?
Way out front here? I could.
Like if it was like a normal one, you would take the exponent and bring it to the front. Why didn't you do that?
I guess I was just finding the derivative of just that part. Are you saying why didn't I write it way back out front? Like this? Because I could have written that out front if I wanted to. In this case, because since it's all multiplication, I can really write it wherever I want to. Unless she's trying to ask something else that you guys can help convey to me a little bit.
She's not finding the derivative of like the whole thing, because she's finding the derivative of 2x.
Okay, so maybe let me write it just a little bit cleaner for you. Square root of 2 times e to the 2x to the 1/2. Okay, so then this square root of 2 is just along for the ride. Equals the square root of 2, just stays there. And then this right here, I think I see what you're saying. It doesn't matter what this is. The derivative of that's just going to be e to that same thing. Okay? And then we're going to take the derivative of that nested function. Is that what you're asking? Why didn't I take this 1/2, put it out there? Okay, because that is all part of my function of my exponent. Okay, so another way we can write this, okay, is the derivative of e to the whatever is just e to the whatever. Nothing changes when we find the derivative. And then we take it times the rate of change of that thing. Okay? So you're trying to use power rule when you're finding the derivative of e to the x. Nope. The derivative of e to the x is just e to the x. Put it this way, the derivative of e to the cow is e to the cow times dcow. Okay. Let's do another one. Y equals x squared e to the negative 2 over x. So what am I going to have to use?
Now we're going to use
Product rule and chain rule. Okay? And we can go ahead and put this in parentheses to let us know that that is my nested function. Okay? There are other ways to tackle this, but I think this is probably the best way in the long term. Okay? Okay. dy dx. I'm just going to sprint through this, and you guys can ask questions if you have them. 2x e to the negative 2 over x plus x squared e to the negative 2 over x. Ooh, and I probably maybe should have written this a little bit different even. Okay, I'm falling into the same trap I fell into last time that caused the confusion. So I'm going to change this. I'm going to change the way I wrote this. You don't feel you got to change it, but so it's going to be negative 2x to the negative 1. Negative 2x to the negative 1. Negative 2x to the negative 1. Okay. Times 2x to the negative 2. So we got the first part of product rule and the second part of product rule. Yes?
With the one before you, since there was a thing inside,
yes.
multiplied by 2, why didn't you do that for this one?
Okay. Because this, on this last one, these are great questions. I'm going to try and colorize this a little bit. Okay. So here was my first function, and here I have another nested function. Okay. So the derivative of the green was this 1/2 2 to the 2x to the 1/2. And then I had to take that times the derivative of the pink. So on this one here, what do we have? This is a green, but there's no other nested function inside of that. Oh, I'm sorry. There's no other nested function inside of that. This is just power rule. It's just x to a power. So we're just going to take the derivative of that x to a power. So I just use power rule. Negative 1 times 2, and then x to the negative 2.
So if there's like a square root and it's 2x, there's going to probably be 2.
Oh, yeah. Yep. And let me do an example of that that's a little bit more complex, okay, to answer your question. Okay, you guys, this is what I'm liking, because you guys are, and this is, you should, the stuff we do at night should be challenging enough that you guys should come back with some questions each day. Let's try this example. Let's do y equals secant of cosine of square root of 3x squared plus 2x plus 1. Okay. What rules are we going to use? Chain rule. Do we have to use product rule? No, we don't. And it might look like it does, because you look. Some people might think it's secant times. No. It's secant of. So this is a function. This is a function with inside that function, and this is also a function with inside that function. So let's peel the layers. dy dx equals what's the derivative of secant? Secant tangent, because on secant there's a second function. So it's secant of this ugly monster times tangent of this ugly monster and are we done? No, I've got to take it times the derivative of what now? The cosine. So I've got this function. So now I need to take the derivative of that function, which is negative sine of that ugly thing. Okay? Okay. So now, are we done? No, because we've got another function that's nested within that function. Actually, no, we've got actually a couple different functions. I got to go orange. I got the square root function that I've got to do. This kind of reminds me of an onion. You peel the outermost layer of the onion, and then you peel the next layer, and then the next layer, and if you work with the onion enough, what happens? You end up crying. There's no doubt about it. So it's very similar to a onion. Okay? So now I've got to take the derivative of the orange, which the orange is that raised to the 1/2 times 1/2. Good. Keep it up. Plus 1. I'll raise the negative 1/2 times
6x plus 2. Yep. Can we just leave it like that on the test?
No, I want that full. No, yes, you can definitely leave. Because imagine grading that. This would be fun enough to grade as it is.
I think we need a whole paper to be able to finish that. A whole one sheet of paper.
I'll give you some good white space. That's
You have to simplify when you have to simplify the first couple. Like how you want it to simplify.
I'm not going to ask you to simplify at all. You just done.
So we just have to like divide it up into the rules and write it all out.
And so like this would be the done problem. So even if you want to, you can go the derivative of this is that the derivative of my green is this. The derivative of my orange is this, and the derivative of my pink is this.
It keeps getting shorter.
Yeah, it does. Thank goodness. It'd be bad if it kept getting longer. Why am I doing this? This is awful. Okay. So, Melissa, is that helping out? I think we identified a couple things. It was a nested function issue that was kind of getting you, and I got you. Okay. So now let's do an example of, we'll probably, I don't know how much time we'll have, so I'm going to get right to a funky one. Y is equal to, let's just do 1 over 2x plus 1. My goal here, let's go like this. I'm going to do two things. I want to find this derivative. So find dy dx. Okay. And I want to find the slope at x equals -1. And the equation of a tangent line at x equals -1. Okay? Oh, this is ugly. Yes?
This is kind of off topic a little bit, but does it matter to you if our notation is the dy dx or like y prime?
Doesn't matter to me. Because that's a great question. You can use f prime, you can use y prime, you can use dy dx, and actually I would like you guys to get comfortable with all of them. But later on, this dy dx is going to be very, very powerful, because later on we're going to be doing something like dA dr, which is going to represent the rate of change of the area in relationship to the radius. So then that notation is going to have some meaning to us. It's going to make me go, ooh, when the radius is changing at this rate, how big is the area changing? So then it'll have some meaning to us. Okay? So here we go. Limit as h approaches 0 of of, I'm just going to plug it in, 1 over 2 times x plus h plus 1 minus 1 over 2x plus 1. Ooh, this one's going to be ugly. Over h. And this one might take me a little bit longer than I anticipated, but that's okay. That's okay. We got 6 minutes. Okay. So this would be one of the harder ones on here, of course. So that equals limit h approaches 0. I'm going to do this fairly quickly. Let's see. I'm going to rewrite it just a little bit. I'm finding a common denominator so I can add these two things together. That's what I'm doing. This is uglier than I anticipated. I'm going to take a deep breath after that one. I plugged in 0 for h. So I found the limit. No, you're asking good questions. That's the interaction that I want.
Would you do one of these on the test or that?
It would just be a little bit easier, but I would say a square root one might be fair. Just to, actually, if I would say the function is square root, I wouldn't be like square root of 2x plus 1, but all that good stuff. I'm not going to do that to you. Okay, so let's think about this as a whole. I want to find the slope at -1. Well, I plug in -1, and my white balance is not adjusting for me automatically anymore. So the slope, dy dx, at x equals -1 is -2 over -2 plus 1, so -1 squared gives me -2. That's my slope. Okay, my slope, I want to find the equation. Well, my question is, -1, what is on my original function? Well, -1, -1. So now I need to write the equation for the line here. And if a person wanted to simplify that, they could. You don't have to, but if you want to, you can. the advantage of simplifying it would be to then you could go in your graphing calculator and type it in and see that it is tangent at that point. That was a long one. Remember, present to me as you're picking up your test tomorrow evidence of studying. If you want to get an early start on it, I'm not going to be disappointed if you come in a little early. I will definitely support that. My quest is to make something that I can get done in 10 minutes so you guys can get it done in 45.